Okay, today we're going to talk about the Algebra 2 standards. I'm going to try to get through this slideshow because this is about the third time I've started it. But anyway, let's go forward. In this slideshow, there's abbreviations and presentation. NCTM stands for the National Council of Teachers of Mathematics. We should know STAR, TEA, TEKS. HECB is the abbreviation I use for the Texas Higher Education Coordinating Board, and TSI is the abbreviation for the Texas Success Initiative. Why do we have mathematics standards? The Higher Education Coordinating Board said mathematics is essential to becoming a productive citizen in today's society. Through mathematics, people become more able to make well-informed decisions by formulating conjectures and testing hypotheses. These are words from their standards or from their literature. The National Council for Teachers of Mathematics states the need to understand and be able to use mathematics in everyday life and in the workplace has never been greater and will continue to increase. In this changing world, those who understand and can do mathematics will have significantly enhanced opportunities and options for shaping their futures. So these are very similar ideas and why each has listed standards and made standards and why mathematics education is important. On the use of technology, the Higher Education Coordinating Board says it's an instructional decision that facilitates the learning of mathematical concepts, and it was decided by them to allow the instructor to determine when and how to use technology based on their level of their student and their needs. But they do state they believe growing technological world requires students to embrace technology and the changes it brings. The National Council for Teachers of Mathematics, however, says technology is essential in teaching and learning mathematics. It influences the mathematics that is taught and enhances students' learning. Technology can support investigation and as students are studying, so that will enhance their learning in every area of mathematics. Now, I have a few comments about technology. It is very important for our students to be able to learn to use graphing calculators and use them well. They are allowed to use them on the PSAT, the PLAN, the ACT, and the SAT. All of these are important for students to get scholarships and to get into college and to later, I'll give you the standards for providing exemptions on the TSI assessment. Algebra 1 is a STAR-tested mathematics course, and the STAR test, whether we like it or not, is heavily geared to mastery of a graphing calculator. Now, students have to know the concepts. They have to know why they're doing math. And so the lower grade levels really have to teach the students the number sense and the number understanding, that numerical reasoning, because they really, by the time they get to high school, we're going to give them a calculator, and it's important that there's reasons that it's important for them to be able to use that calculator. Now, another reason though we can't let them get too calculator dependent even in high school is this last bullet. The TSI assessment does not allow the use of a graphing calculator. There are some questions where there's a little button for a pop-up calculator and it's a very simple calculator, and there are some questions where there is no calculator available to them. So we cannot in high school undo the work that's done from the early grades and let them become so dependent on a calculator that they don't remember how to do any of that math by hand with just a paper and pencil. There's 6 principles the NCTM states is important for teaching mathematics. Equity, there's excellence in mathematics education requires equity, support for all students. The curriculum has to be more than a collection of activities. It has to be coherent, focused, and well articulated across all grades. Effective mathematics teaching requires understanding what students know and also where they're going, what they need to learn, and then challenging and supporting them to learn it well because they're going to need it later. You know, mathematics builds and builds and builds and builds. And so what they learn, when they learn fractions, they need them in algebra. And they need them more than they need decimals in algebra. So it's important that we understand that they've got to learn it. Then students must learn mathematics with understanding, actively building new knowledge from experiences and previous knowledge. Assessment should support learning of important mathematics and furnish useful information to both teachers and students. And this technology quote is the one I did earlier from NCTM, and so I'm not going to read that one again. Then NCTM also has process standards. The first one involves problem solving. These process standards are all start out with instructional programs from pre-kindergarten through grade 12 should enable all students to. So they're very broad because they go from pre-K through grade 12. And this one, they should build new mathematical knowledge through problem solving, solve problems that arise in mathematics and other contexts, apply and adapt a variety of appropriate strategies to solve problems, to monitor and reflect on the process of mathematical problem solving. Then there's reading and proof. Students should recognize reasoning and proof as fundamental aspects of mathematics, make and investigate mathematical conjectures, develop and evaluate mathematical arguments and proofs, select and use various types of reasoning and methods of proof. Next we have communication. Instructional programs from pre-kindergarten through grade 12 should enable all students to organize and consolidate their mathematical thinking through communication, communicate their mathematical thinking coherently and clearly to peers, teachers, and others, analyze and evaluate the mathematical thinking and strategies of others, and use the language of mathematics to express mathematical ideas precisely. They should be able to make connections, recognize and use connections among mathematical ideas, understand how mathematical ideas interconnect and build on one another to produce a coherent whole, and to recognize and apply mathematics in contexts outside of mathematics. And last, we have representation. They should be able to create and use representations to organize, record, and communicate mathematical ideas, select, apply, and translate among mathematical representations to solve problems, and to use representations to model and interpret physical, social, and mathematical phenomena. The TEKS, there are 6 basic understandings. These are more specific towards what's to be taught rather than the process standards that we just went over. This first one deals with what they should have learned in grades K through 8, the basic understandings in number operation, quantitative reasoning, patterns, relationships, algebraic thinking, geometry, measurement, probability, and statistics are essential foundations for all work in high school mathematics. I would say especially probability and statistics in the sense that they're all important, don't get me wrong, but the TSI assessment that they take in high school, or that they will take to get into college, has probability and statistics in it. And we don't teach a lot of that in algebra, geometry, and algebra 2, although I think we're going to need to start incorporating it. If they don't take statistics in high school, then that, what they get in the lower grades may be basically mostly what the statistics they are exposed to. And yet they're going to have to answer some questions on the TSI assessment that involve a little statistical knowledge. Algebraic thinking and symbolic reasoning, functions, equations, their relationships, that's huge in algebra. Relationship between algebra and geometry, tools for algebraic thinking, underlying mathematical processes. Now we're going to get to the part where I compare broadly. I didn't go into a lot of specifics with STAR versus TEKS versus the NCTM standards. Also included the TSI standard, or the college readiness standard. STAR has 7 broad categories, and within each category are readiness and supporting standards that spell out more specifically what is to be taught as part of the Algebra 2 curriculum. We have properties and attributes of functions, representational tools to solve problems, properties of quadratic functions, representations of quadratic functions, properties of square root and rational functions, and properties of exponential and logarithmic functions. Then we have the TEKS. The TEKS are pretty much the same as the STAR, but they have the student expectations. They're more specific with the student expectations, and those are in the A, B, C through G, however many there are. Those are the student expectations. So foundations for functions, there's 3 categories with 7 student expectations. Algebra and geometry, 2 categories with 8 student expectations. You can see that quadratic and square root functions is very large, very big part of Algebra 2. Lots of student expectations for TEKS. Rational function just has 1 TEK, but quite a few student expectations, 7. Exponential and logarithmic functions, same sort of breakdown. The TEKS, I didn't write them all out because it would have just been a lot of slides, but the link at the bottom here is for the Algebra 2 TEKS if you want to look at them. The NCTM standards for grades 9 through 12, and it's broad, it's not for one particular topic, it's for grades 9 through 12, is number operations, algebra, geometry, measurement, data analysis, and probability. Now we're going to use number operations in every math. We'll use measurement to some extent in every math, but mostly in geometry, and then quite a bit in science. Algebra, of course, will deal with, use algebra and geometry a lot, but algebra is the one I'm going to focus on. And then data analysis and probability is mostly in your statistics. And you can actually do a lot of data analysis and probability within a science class as well. The NCTM Algebra Standard, there are some subcategories among these, and I did not list them all, but they are much less specific than the TEKS and the STAR categories. The first is understand patterns, relations, and functions, represent and analyze mathematical situations and structures using algebraic symbols, use mathematical models to represent and understand quantitative relationships, and to analyze change in various contexts. But they are similar categories. They're very, they relate. The TEKS, the STAR, the NCTM standards relate very well. They're just spelled out in more detail with STAR and the TEKS. The college readiness standard involves numeric reasoning, algebraic reasoning, geometric reasoning, measurement reasoning, probabilistic reasoning, statistical reasoning. Very much what we just saw in the NCTM standard. Then there's functions. Then if you look at these bottom 3, problem solving with reasoning, communication and representation, and connections. If you go back to those NCTM process standards, that's what those represent. So the college readiness standards listed for us here line up very well with the NCTM standards. For my local curriculum, we have a TEKS-based curriculum, and it's designed to support STAR standards. We're given a year at a glance and 6 weeks calendar, and we have a little book that's given to us. It has lots of different resources and questions that are lined up, a vertical alignment of what's taught when and at each grade level. So we're given a lot of resources. We're all given a book that we can draw from. I use another mathematics resource that I've used for years. The district gives 3 CBAs a year in all math classes. through Algebra 2 and a star benchmark in Algebra 1. Since we're in early college high school, we have a particular drive for our students to get TSI, to get college ready, or in other words, to pass the TSI assessment by the end of their sophomore year, hopefully by December of their sophomore year. We hope for all our students to be able to go into college algebra by their junior year, and many will go into college algebra by their end of their spring of their sophomore year. They do this because some of them that are trying to get their degree in their associates in a science or a engineering type curriculum need that time in order to be able to meet the math requirements for their associate's degree. We do have some that are seniors that are just now going into college algebra, but we really are trying more and more every year to get them college ready earlier. Now, I want to talk a bit about the TSI assessment. There are a lot of exemptions, and I think any of you that teach in high school need to be aware of these exemptions, because it's important for our students not to go into developmental classes. It really reduces their chance of ever getting a degree if they even take one developmental class. And that's a research, and I should have looked it up before I started this, and I didn't, but that's research. That's a research-based statement, and I have seen the percentage, but I can't tell you what it is. But with tax, there's a minimum score of 2,200 for both the English and our math sections, and at least a 3 on the writing component. If they achieve that, they are exempt from taking the, if they get the English then and the writing score, they don't have to take the reading or the writing TSI. And if they get the 2,200 plus on the math, they don't have to take the math TSI. Now, again, our seniors are at this, they're the last group that has taken tax. But anybody that's a senior this year is exempt with those scores, and I think they need to know that. Star, if they have a minimum score of level 2 on the English 3, then they're exempt in reading and writing, and a minimum score of level 2 on the Algebra 2 EOC. They're exempt for the mathematics portion. Now, some schools could quibble over whether it's the phase-in level 2 or the final level 2. In algebra, I'm not sure in English, but in algebra, the phase-in level 2 standard was 3,500 for a scale score, and the final level 2 was 4,000. And I think that some will honor the 3,500, but I have seen a few colleges that specifically list the 4,000 requirement. And any student, this is from the Education Code, any student who's been determined to be exempt from these standards shall not be required to enroll in developmental coursework or interventions in the corresponding area of exemption. And that's really a big deal. The problem is once they get there, they have to have the work ethic to succeed. And I've seen students with low scores on their college placement that succeeded in the college classes because they had the work ethic, and others that had plenty of high scores that failed the class because they didn't have the work ethic. So, there's a lot of things we need to be stressing to our students as they go forward into college. Also, 2 other tests I wanted to mention because students are the ACT and the SAT. ACT, they have to have a composite score of 23 and a minimum of 19 on the English and on the math to be able to be TSI exempt. The 19 will exempt them from both the reading and writing sections, and also the 19 in the math will exempt them from the math portion. SAT, they have to have a 1,070 with a minimum of 500 on each of the tests. And so it's really critical that we let them know these things so that they'll know that that will exempt them from having to take these this TSI college entrance test. There are some military exemptions and some other exemptions. There's some old scores that used to be used. They used to use the Accuplacer, the Thea, the Compass, the Asset, multiple methods of tests, and different colleges use different ones for college entrance and to place them in the developmental classes. The Higher Education Coordinating Board has said, no, we're going to this one test, this TSI test. And so that we need to know the exemptions for that. And I will tell you that it is easier. I mean, it's mostly Algebra 1. For sure, by the time they get through Algebra 2, if they are comfortable with that material, they should be able to pass that TSI mathematics assessment. I do not know about the reading and writing. But there is more information at this link on the exemptions for the TSI assessment.